what we're going to do is learn to solve a Hess's law problem. Now, what I did was I gave you a copy of this worksheet that has this exact same problem on it. What I want you to do is watch as we're going through this video, pause it as you need to, and go ahead and make sure you have this problem written down. Maybe take some notes as you go through this so you know how to solve a Hess's law problem. They're not very difficult to do once you get the hang of it. It does take a little bit of time to learn to do it. Basically, anytime you have a Hess's law problem, what you'd have is an equation that you're trying to figure out what the delta H is. In this case, that first equation, tungsten plus graphite yields tungsten carbide. We want to know the delta H for that reaction. That reaction is kind of hard to determine the delta H for, so as long as you have some other equations, you can use Hess's law to figure out what the delta H for your unknown equation is. Why? Because Hess's law tells us that if we take several equations and add them together, we should be able to get the delta H's added together as well. Ultimately, what we're trying to do is come up with that equation there by manipulating these equations down here at the bottom, the three that I have numbered 1, 2, and 3. Sometimes the worst part in these problems is just getting yourself started, and I think the best thing to do is look for something that appears in your unknown equation, that's our top equation up here, and appears in only one of our known equations, that's the equations down here. And if you look carefully, you can see there's a couple things that actually will work for us in that respect. One of them is tungsten. If you look, I need tungsten in our equation, and this right here is the only place that tungsten appears in our three equations. No other place do I see solid tungsten by itself. So I know that's what I'm going to have to use to get that particular tungsten. If you look, you can also look for graphite. This is the only place graphite appears, and it's in our unknown equation. And the same thing, we've got tungsten carbide, and there's only one place that appears, and that's right there. That's usually the first place you want to start with these. As you do more and more of these problems, you'll begin to see how those things work and how you can actually identify them to get yourself started in these problems. Let's go ahead and deal with the tungsten in this problem. What I always ask myself is, how many do I actually need, and on which side of the equation? And you can see I need 1 mole of tungsten on the left side of the equation. 1 mole of tungsten on the left. In this equation, I've got 2 on the left. So I know it's on the correct side of the equation, but I don't have the correct number of moles. So what can we do to get from 2 moles down to 1? Well, that's right. We're going to go ahead and we're going to divide this equation in 2. And that's going to go ahead and give us the correct number of tungstens. All right, so let's take tungsten. Again, it went from 2 moles down to 1. We've got 3 moles of oxygen in our equation. And when I convert that, or excuse me, divide it by 2, it's going to give me 3/2 moles of O2. Believe it or not, you probably want to use fractions in these problems. It's going to be a little bit easier for you. And that's going to yield, let's see, 2 moles of WO3 become 1 mole of WO3. Again, I simply just divided all the coefficients by 2. And as we know, delta H can also be divided by 2. It's still negative because we didn't flip the equation, but it's now going to be negative 840.3 kilojoules. Why? Again, because we flipped the equation in half. What you can then do is the graphite equation. Same thing. Let's take a look. We need 1 mole of graphite on the left side of the equation. It appears we've got 1 mole on the left. So what do we need to do to this equation? Well, it doesn't look like we need to do anything to it. We've got what we need in the quantity that I need on the right side of the reaction. So let's just go ahead and copy the equation down. Since I didn't do anything to it, my delta H still is negative 393.5 kilojoules. And how about for tungsten carbide? Well, it looks like I need 1 mole on the right, and what do we have? I have 2 moles on the left. Okay, well, what does that mean I need to do to this equation? Looks like I'm going to need to flip it to get the tungsten carbide to the correct side of the equation. And it looks like I'm going to need to divide by 2 to get the correct number of moles that I need. So go ahead and flip that equation, divide by 2, also do the same thing to the delta H, and then watch the second part of this video and we'll pick up from there.